What happened? Hello? Buti ka-beverage ako guys. Inhale. Inhale. Exhale. Inhale. Exhale. Because I just finished my cardiovascular exercise. Jogging in the oval zone. Okay, so let's go back. Wearing yellow. Oh my gosh. So let's do another problem for tonight. Tonight, right? Tonight is the night. But as usual, going back to business. Okay. Business galore. Okay. Problem number 2. This is 2, right? This is 1. A 10 kilogram black aluminum with a density of 2,700 kilogram per cubic meter. Okay. Attached to a rope. What is the tension force in the rope if the black is in a vacuum? B. What is the tension force if the black is in the air? 1.29 kilogram per cubic meter. C. What is the tension force if the black is in water? So we need to analyze. There are 3 situations. First, the black is put into the vacuum, meaning there's no medium. Medium meaning liquid, water, air. Okay, vacuum at first. Second, we have air, and third we have the water. Okay, so we do the vacuum first. Okay, if we try to attach the rope, this is 10 kilogram, this one, 10 kilogram, okay, of the black. So your vacuum is an empty container. Because of this vacuum, there's no air, there's no water, there's no sea. Empty. That is what we call as vacuum. Okay, like that. And then, so your rope is here. Okay, so rope has a tension force T. Okay, we don't have buoyant force in a vacuum. Okay, we don't have buoyant force in the vacuum, so we have the weight going downward. Okay, so summation F net. Okay, vertical is equal to positive T minus weight. So F net is equal to 0. Okay, the tension is just equal to weight. Weight is mass times acceleration due to gravity. Mass is 10 kilogram and acceleration due to gravity is 9.81 meter per second square, and we have 981 Newton. This is our tension. Okay, ganon. This is for the letter A. What is the tension force in the rope if the black is in vacuum? Okay, this is letter A. So letter A, we answer the letter A. So this is 981 Newton. Okay, B. What is the tension force if the black is in the air? So we fill now this with air. This one, air. So the air will exert an upward force, okay, equal to the weight displaced of an object, going downward. So this is now our buoyant force of the air, which is, let's see, FA. Oh, so again, doing the summation of all forces, okay, F net vertical again is equal to tension again is positive T, right? And then weight is downward. 9.81 times 10. Okay. And then positive FD. Right? Canon. Then we have now the F net is equals to 0. So you will say tension negative minus 981 plus F. What is your FD here? This is now your formula of your buoyant force. Okay, I will erase now here. Okay, because there is already buoyant force when you, okay, immerse this black into the air in a regulatory situation. Okay, like that. Okay. So, buoyant force, this is buoyant force Fa is equals to the density of the air. Okay? Like this. The volume of the aluminum. Okay? Aluminum and the acceleration due to the gravity. Always take note that your volume will be based on the object being immersed, not the fluid. Take note for this buoyant force. And then your density will be the fluid, the liquid, the air, so that it's easy for you to analyze. Maybe you will compute also the density of the volume. So no good. Okay? It will be redundant because you will also compute for the density here of the volume, in the volume of the aluminum. Okay? So this is as acceleration due to gravity. So density of the air, mentioned? Yes, mentioned. See? 1.29 kilogram per cubic meter. Volume of the aluminum. So you have the formula, density is equal to mass over volume. Okay? Volume is equal to the mass, which is 10 kilograms. See? And we have also, this is the mass, right? And then mass over density mentioned of the aluminum. So 2,700 kilogram per cubic meter. See, this is the volume of aluminum, not the fluid. Right? Okay, so cancel, we have now the volume. 10 divided by 2,700. So don't be confused for that. The volume here is always the object being immersed, submerged, not the volume of the fluid. Okay? But the density here, beside the volume, is always the fluid, the liquid, or the air. Like that. So you will not be confused. Okay? So, 10 divided by 2,700 is equals to 0.0037 to 0.0037. 123, right? Okay. Like that. And this cubic meter. Cancel. Acceleration due to gravity is 9.81 meter per second squared. So kilogram meter per second squared. So this is our Newton force. Okay, mga palangga, kumita. Times 9.81 is equals to times 1.29 is equals to, we have 0.04687. 0.04687 Newton. Okay, do it again because this is very small. Maybe wrong. So 1.29 times 0.0037 times 9.81. Yes. So that is the Newton. So substitute that here because we are now, the FB here is the FA, which is the upward force, the buoyant force of the air. Okay, so you will say tension, okay, minus 981, right? Plus 0.04687. So tension is equals to, so subtract that one first. Okay, this negative of 981, negative 981, sorry, plus 0.04687 is equal to negative 980.9. So this is going to be tension positive 980.95 Newton. Okay, it's going to be like that. Actually, basically, the tension of the second will be nearly close to the tension in the vacuum. See? Because the tension in the vacuum is 981, and the tension also of the air is 980.901, only 0.9 something, because you know the density is very small, the density of the air. Okay? Like that. And then letter C na top. Okay. Letter C, maulang yapon mga kalangga. Okay? Letter C, but your total summation of forces will be like this. F net is equal to, ano siya? F, this is the tension of the black water. So FW, positive W minus, okay, minus weight, then plus tension. So 0, so FW will be equal to the volume of the fluid. Okay, the density of the fluid, how much? Okay, given siya 1,000, diba? Kilogram per cubic meter. Okay, then volume of the water. So density, mass over volume. Then volume is equals to mass 10 over 1,000. So cancel. So 10 over 1,000 kilogram per cubic meter, right? And then kilogram, cancel, kilogram, and then 9.81, right? Minus 9.81 times 10 plus tension. Yan. So you can compute for the tension. Okay, ana siya. So it could be cancelled automatically. This is 1,000 from the numerator, from the denominator. So cancel automatically. Okay? So 10 times 9.81. 10 times 9.81. 9.81. Okay? Like that. So 9.81. 9.81. Okay, 10 man siya. 10 times 9.81. 28.1. Charot. 9.81 times 10. 9.81 times 10. 9.81 plus E is equals to 0. 0 plus E is equals to 0. Tension is equals to 0. Okay? Ganon. Your tension will be equal to 0. Here. Okay? Like that. Wait. This is the volume of the object, not the water. So this is gonna be 2,700. Because it's impassible, the tension is 0. Okay? As I told you, volume of the object. Okay? Not the fluid or not the air. Kakaloka? O diba? So if you analyze, you'll correct immediately. Okay? Ganon times 1,000 times 9.81 is equals to minus 9.81 is equals to, so tension is 26.53, right? So 2,700 times 1,000 times 9.81 is equals to minus 9.81. Okay. 9.81 times 700, 98.1. 98.1. See? O sarap siya ka-0, guys. O, diba? 1,000 times 10 divided by 2,700 times 9.81 minus 98.1. Really? 10 times 2,700, the calculator, times 1,000. And then times 9.81 minus 98.1. Yes, 61.77 tension. Tension is 61.77 Newton. Okay, for letter C, 61.77 Newton. So the tension in water is lesser than tension in the vacuum. Yes, because there's no force applied up, right? Letter C. And then your tension here is closer to the vacuum. Letter D is 98.01 something blah blah blah, so it's alright. 98.10 something blah blah blah. Close because air is very light. Okay, closer to vacuum also, right? To the point, wala siya. Diba? Any questions so far for this? Nothing, right? So you can comment, you can like this review. Okay, very cold. I must off the AC. It's very cold. Okay, so it's gonna be like that. So the tension force of the air and the tension force of the vacuum is very close with each other. Okay, because the density of air is very light. Okay, very light. So something like that. So you can comment, you can like, and then you can share to anybody else who have subjects physics. Okay, and then you can teach also your sons and daughters to their assignments, something like that. And then you as a students also, you can take down this kind of problem, especially if your topic now is regarding buoyant forces. Okay, like that. Any questions so far? And then you can subscribe my YT channel. Don't forget to click the like button as our first rule in watching the video. And then you can also click the notification bell for some US updates that I am a singer in our voice. Bye bye, God bless everybody. See you for the second example. And after that, we will be going to another topic. Okay, we will be touching gravitational force and electrostatic force, right? Okay, thank you so much. Bye bye, God bless everybody. Okay, ganon.